Hello all, welcome to my YouTube channel. Today we will learn about the performance matrix. I know we already worked on classification problem, but today we will learn more in depth about the performance matrix. So performance matrix, because these are the matrix will help us to judge whether our model is working good, or if we have to compare our model with one model to another model. Okay, let's consider some data points. Actually, let's consider we have x2 x1 two data points, and we have y actual and y predict, y pred, or I will say y hat, whatever you can say. Let's consider, because it's a classification problem, we are talking about everything related to classification. And the example which I'm showing here, I'm considering it's a binary classification, so 0 and 1. Okay, so let's consider I have a real data where my y actuals are something like this, but after the model training I am getting output something probably like this 0 to 0, 1 to 1, probably these are right, 0 to 1, or probably 1 to 0. Okay, now normally what we do immediately after this, we build a confusion matrix. Okay, try to understand. Okay, so this is very important, because internally when sklearn, if you're calling a confusion matrix, it's doing exactly same thing. So what it is doing, it's kind of creating like this kind of box, and in this side I have actual, and in this side I have the prediction values. And let's consider this is 1, this is 0, this is 1, this is 0. So how we'll plot, actually, like if the actual value is 0 and the predicted value is 0, then we will put it in this box. If the actual value is 0, predicted value is 1, then we will put it into this box. Let's now check one by one each of this. Let me change the color of my pen. Let's consider this first one. So you will understand actual is 0. So actual is 0 mean in this box, but y predict is 1. So prediction is 1. So it will be in this box. Okay, because actual is 0, predicted is 1. Okay, similarly, when actual is 1, predicted is 1, it will go in this box. When actual is 0, predicted is 0, it will go to this box. So if we plot these things properly one by one, you will see ultimately what will happen. How many we have? 1 1. So 1 1 1. So we will have 3. So that's, let's consider here it is the 3. And how many actually? Actual is 0 and actual is 0, but predicted is 1 is this one, and actually 0, predicted is this one. So here it will be 1 plus 1 equal to 2. And how many is actual 1 but predicted is 0? Actual 1, predicted is 0, the last one. Okay, so the last one will go into this box. Okay, now at the same time you have to remember this thing, like how to basically call this individual block. Okay, so what we are doing basically here, so this block is telling me how many are true positive. So this is calling me to true positive. Okay, makes sense? True positive, because Actual is also positive and predicted is also positive. True positive. And this is my true negative because actual is negative and truly I am predicted it's negative also, which is fine. But this one, let's consider this is actually my negative value. This is actually my 0, right? If you consider this again, this is the actual, let's don't confused, and this is predicted 1 comma 0 1 0. So this is my false positive. Why false positive? Because this is actually 0 but model predicted this one as 1. So this is my false positive and this is my false negative. Okay, first try to understand this confusion matrix. Once you understand this confusion matrix, after that calculating all the different metrics like our accuracy, precision, recall, F1 score, everything is just a formula. You can easily understand this thing. This is not a big deal. Big deal is this thing. Understand this plot and understand which one is my true positive. So in this case, what is my true positive? My true positive is 3. What is my false positive? My false positive is 2. False negative is 1 and true negative is 1. Understand this piece first. Okay. Hope take your time, understand this, and then we'll go for the actual calculation, like how to calculate the accuracy, precision, recall, and F1 score. Okay, so now what is the formula to calculate the accuracy? Okay, the formula is very simple. True positive plus true negative divide by all the values. Basically, true positive plus false positive plus false negative plus true negative. So in this case, if we plot all these things, 3 plus 1 divide by 3 plus 2 plus 1 plus 1. So ultimately, it will give me 4 by 7, which is 0.5 or 57% actually. What is that? Let me use my calculator. C. Let's bring up my calculator actually. 1 second. Let me bring my calculator here. So 4 divided by 7 is 57%. Yeah. So it's around 57%. Okay. So that's my accuracy. Okay. So this is the way we will calculate the accuracy. And if your data is not imbalanced, so remember this, if your data is not imbalanced, imbalanced, then accuracy is very nice metrics. You can completely rely on accuracy if your data is not imbalanced. Okay, now we will learn how to calculate the precision and recall and why they are so important. Okay, now we will focus on the recall. Okay, so let me write recall, and the formula is TP by true positive by false negative. So here, this is very important. This false negative is very important. So what exactly it's mean? What it is trying to say? It's saying out of all the actual positive values, how many of them are truly predicted 1. So this is very important. Why important? Depending on your data, this parameter may be very, very crucial. For example, if you have some kind of a data where you are trying to identify whether the person is actually having a blood cancer or not. Okay. Now, in this scenario, what is important? If you suppose the person, so two scenarios is possible. One, person might have a blood cancer and person does not have a blood cancer. This is the actual value. And Y hat can be two things, right? Either when the person is actually having a blood cancer, and if you denote it, no, person does not have blood cancer. This is very bad. This scenario is very bad. This is very, very bad scenario. Why? Because that means the person is actually having a blood cancer, but your model is saying, okay, no, you do not have a blood cancer. So then it's a problem, right? Because the person might get infected. But on the contrary, like if the person does not have a blood cancer, but the model probably predicted some blood cancer, okay, person can go and take another opinion. So this scenario is where recall is very, very important. We want to make sure that our recall value should be high. So this is very, very important scenario where we have to consider recall. Okay. Now coming to another important matrix, that is called precision. Why, when we are I think in my lab work I will show you more, but there is one more. This is called precision. Okay. Now precision formula is TP, true positive, by true positive by false positive. So this is again very important. Okay. So what it is trying to say here? It's trying to say that out of all predicted positive values, how many are actually positive. And let's consider one example, like where this is very important, where we will focus on the more precision parameter. Suppose we are doing a spam classification, SPAM, right? Spam classification. Suppose we are doing a spam classification. In this case, we will more rely on the precision, because in this case we want to rely on, or out of all predicted positive values, how many are actually positive. So here, like if you have out of 90, out of 100, probably 90 if you predict as a spam, then everything will go into the spam folder. So we don't want that. So that's why here the precision is important. Okay, the recall and the precision. Okay, clear up to this? And in my next example, like in the practical example, we'll go in the more detail of each of these parameters. Okay. Now the next one, which normally we called F1 score, F1 score, the actual formula is actually F beta, where the formula is 1 plus beta square precision into recall divided by beta square into sorry precision plus recall. Okay, now when we are equally important, like when recall and precision both are equally important, precision both are equally important, that time we consider beta value as 1, and this formula then comes like 2, like I'll just make it PR divide by P plus R, and this is called harmonic mean. Harmonic mean. Okay, and this is not lot of time we used when it is both of this, recall and precision, both of them are important to our scenario, our data example, then we normally consider this. So if both of this are equally important, then we will calculate the F1 score and we'll judge it by this. Okay, so these are the main metrics when we do the confusion matrix. So let's go up. I'll probably give this notebook into my GitHub page. So what we learned for the classification problem, the metrics, we have 4 different metrics, primarily accuracy, precision, recall, F1 score. And for that, first we create a confusion matrix. Manually also you can do it, but in sklearn there is a package called confusion matrix. You can use that package. Otherwise, just try to understand what exactly happening on the back end. Like you just need to understand this thing, how you're plotting in this box. If it is true positive, put it into this box. If it is false positive, put it into this box, and understand this part, actually this calculation. This is the main part. If you understand this part, then after that it's just putting into the formula: accuracy, recall, and precision, and F1 score. And then understand like in which scenario which matrix is very important. Like as I mentioned, like if this kind of a scenario where your positive value, like if somebody has a positive value blood cancer, but your model is predicting, that's very bad, right? You cannot do that. So in this case you should consider recall, and recall should be high. Whereas in the spam classification, your precision needs to be high. And F1 score is another example where probably you need both. And one of the example for F1 score, like in which scenario you will think about that, probably if there is you have to do a prediction, like whether stock market, yeah, probably if stock market is going to fall, yes or no, yes or no. This kind of a scenario where both is important, because you don't know like which one is important for you. That's the case, you have to do the F1 score. Okay, and when you are doing the F1 score, the formula is 2 by P by R, which is nothing but your harmonic mean, and that's the way we are calculating the F1 score. And in my next classification problem statement, we will deal with these things and we'll explain more on these things actually. Okay, thank you so much for listening this. If you like it, please give me a thumbs up or just subscribe my channel. See you very soon in my next video. Thank you all. Have a good day.